Let us solve one problem to understand all the expressions of the rotation axis and the principal axis which we had derived last time. Now here we have a z section, and then here there is a centroid of it. This is the centroid of it, C, and then we have one reference axis here, x and y, passing through this centroid. And then they have already given us the moment of inertia about this x axis and y axis. That is, the x-axis is the centroidal axis passing through C, and then y is the y-axis passing through C. They have already given us the moment of inertia about those axes. And then we need to determine the magnitude and orientation of the principal centroidal axis and moment of inertia, the expression of which we had already seen last time. And then we also need to determine the moment of inertia about the new axis x1 and y1, about the new axis x1 and y1 for a angle of 30 degrees. So if what he wants to know is, if I rotate this axis or the frame of reference by the angle of 30 degrees, what will be the value of moment of inertia about this new axis, for which also we had already seen the expressions in our last session. So let us start. Let us see how to determine the magnitude and orientation of the principal centroidal moment of inertia. Before that, he has given some data here. He is saying that h is 200 mm. So this total length is 200 mm. That means this is 100. This is 100 and this is also 100. So because total h is 200. The thickness is 15. That means this is 15. This is 15. This is 15. So this thickness is 15. This is 15, and also this is 15 from here to here. This is also 15. Here, this t is 15. And then he's saying that B is 90 mm. That means this distance from here to here, it is 90 mm. It is 90 mm. So since this is a composite section, the way we were solving the problems in centroid and moment of inertia, we are now already aware that this kind of problems can be easily tackled by just dividing this into the shapes of whose properties are already known to us. So I will divide this z section at this junction and at this junction, and calling this as my first component, this as my first component here, this as my second component from here to here, and this as my third component from here to here. From here to here is my third component. Now we will be requiring some more data, that is the centroid of this part, the centroid of this rectangle will be somewhere here. It will be at a distance of 7.5 mm from this and 7.5 mm from this, or it will be at a distance of, since this b is 90, it will be at a distance of 45 from this end, or 45 from this end. Similarly, the centroid of this will be here exactly at the center. So this is 100, this is 100, this is 15, this is 15. So 15 plus 15 is 30, and this total is 200. So distance from here to here will be 170, or this will be 85. From here to here it will be 85, and from here to here again it will be 85. So this is what we need to know, and then we are good to go. So initially he has asked us to determine the magnitude and orientation of principal centroidal moment of inertia. Now if you remember, the orientation of the principal axis can be given by this formula, whereas the values or the magnitude of the moment of inertia about the principal axis can be given by this formula, the formula which we had already derived in last session. Now if you look here carefully, if I want to find the orientation, or if I want to find the magnitude of the moment of inertia about the principal axis, I require Ix, Iy, that is moment of inertia about x-axis, moment of inertia about y-axis, and also I require the product of inertia Ixy, even here I require the moment of inertia about x-axis, y-axis, same here x-axis, y-axis, and along with that I require the product of inertia about x and y-axis. These two values are given to us. These values are given to us. But what about Ixy, the product of inertia value? That is what we need to determine first in order to determine the magnitude and orientation of principal centroidal moment of inertia. So for that, if you remember in the session of product of inertia, we had seen that the product of inertia can be found out by this expression. Product of inertia Ixy can be found out as Ixy self plus the summation of area multiplied by x distance multiplied by y distance, and this can be found very easily by using this table, so first, in first column of this table we have the number of components. In this case we have three components, 1, 2 and 3. So I can write them as component I can write them as component 1, component 2, and then component 3. Now area of component 1 will be this is 90 and this is 15. So the area of component 1 will be 90 multiplied by 15. So this gives us 135. So this gives us 135 and then 0, 1350. Similarly, the area of the second component will be 85 plus 85, that is 170 multiplied by 15. So it will be 170 multiplied by 15, which gives us 2550. So this will be 2550. And similarly the area of third component, that is this is 90 multiplied by 15, which is same as the first component, so I can directly write it as 1350. Now I require x bar. X bar is nothing but it is a distance between x x bar is here, it will be for the first component, so it will be x bar 1. It is nothing but the distance between the centroid of the first component, and with that of it is the distance between the centroid of the first component and y-axis. So basically we are interested to find this distance. It is a distance from here to here. It is the distance from here to here. This is the distance which we are interested in. This is the x1. Now from this point to this point, this total distance is 45, half of 90. But this distance from here to here, it will be 15 by 2, because this thickness is 15, so this is 15 by 2. So this distance from here to here is 45 minus 15 by 2, which is 45 minus 7.5, and 45 minus 7.5 will be 45 minus 7.5 will be 37.5. So this is 37.5. Similarly, the x bar 2 will be the distance between centroid and y-axis. Now here the y-axis is exactly passing through the centroid. So this distance will be 0, because there is no distance between centroid of the second component and y-axis. It is 0. Then the x bar 3 is nothing but this distance, the distance between centroid of this and y-axis is again equal to it will be again equal to this value, that is 37.5, that is 37.5. But let me remind you again that this component here, component 1, is in second quadrant. So with respect to y-axis, this distance should be negative, this distance should be minus. So this should be, actually truly speaking, this should be minus 45 and plus 15 by 2. This should be minus 45 and plus 7.5. So this should be minus 37.5. The first value should be minus 37.5, whereas this third value x bar 3 is this side, it is on the, it is in the fourth quadrant. This is first quadrant, this is second quadrant, this is third, and this is fourth quadrant. So this will be a positive value. So this will be 37.5. Now let us find y bar. So y bar 1 will be distance between x axis and the centroid of first component, that is from this point, that is from this point to this point. From here to here it is 85, and from here to here it is 7.5. So 85 plus 7.5, 85 plus 7.5, and that should be 85 plus 7.5, and this should be equal to 92.5. So 92.5, this should be equal to 92.5, and then that value is positive, because it is in second quadrant. In second quadrant this value is positive, only the x coordinate is negative, so this should be positive value. Whereas in fourth quadrant this value will be negative, and it will be negative 92.5 for y bar 3, that is the distance between centroidal axis x-axis and the centroid of this third component. This will be minus value, since it is fourth quadrant, and it will be minus 92.5. And again this value y bar 2 value will be 0, because the centroid of second component passes through the x-axis, and this value will be 0. So finally, I want this value, that is ai, xi, x bar I, y bar I. So it will be multiplication of this value multiplied by this value and multiplied by this value. And if we do that, it will be 1350 multiplied by 37.5, which is minus, and again multiplied by 92.5, and that is this 46. It should be minus 4682 812.5. So it should be minus 4682 812.5. This value will be 0, because here x bar and y bar are 0. This value will be again same, minus 4682 812.5. And last column is ixy self, and if you remember, it is ixy self, meaning it is a product of inertia about the centroidal axis. And since all these components are rectangle, the product of inertia about the centroidal axis will be 0, because it will be a symmetric component. So it will be 0. So ixy will be 0, 0, and 0. So this summation will be 0, and this summation 4682812.5. So this is this plus this, so I can directly multiply this value by 2, and it is, will get this 9365625. So it will be 9365625, and it will be minus. So this is what I get here. So finally, I can find Ixy as Ix, summation of Ix self, which is 0, plus summation of this quantity, which I have already got here. So this will be minus 9365625. So I get this value of Ixy as minus 9.3656 multiplied by 10 to the power 6. So once I get this value Ixy, I can substitute it here in this, and I can very well find now theta p and I1 comma 2, that is the moment of inertia about the principal axis. So tan 2 theta p, tan of 2 theta p, tan of 2 theta p will be equal to tan of 2 theta p will be equal to minus 2 times ixy. Ixy we get it as we have already got it as 9.3656 multiplied by 10 to the power 6 divided by ix minus iy. We have already these values are already given to us, so that is 29.29 minus IY. IY is 5.667. It is 5.667, and again this is multiplied by 10 to the power 6. So I can very well cancel this value and this value. Therefore, it, theta p will be tan inverse of it will be 2 times 9.3656 divided by this value 29.29 minus 5.667, and this divided by 2. So theta p will be equal to tan inverse of, we have shift and tan, so this is tan inverse of 2 multiplied by 9.3656 divided by 29.29 minus 5.667 and if I close this bracket I should get this value as 38.41, and that is divided by 2. So I need to divide this answer by 2 and I get this as 19.205. So I can say it as 19.21. So this is the value of theta p. So theta p is nothing but it is the orientation of a principal axis with respect to x-axis. So our first principal axis will be at an angle of 19.21. So it will be somewhere here. The first principal axis will be at an angle of this theta p is 19.21, and the second principal axis will be perpendicular to this new principal axis, which I can call this as xp. xp stands for principal axis in x direction, and the yp will be perpendicular to this, or plus 90 degrees to this. So theta P2 will be 90 plus theta P1, and that will be equal to 109.21. So this is all about the orientation of principal axis, and if I want to find the magnitude of principal axis I can use this expression, and then this will be equal to, I know what is Ix and Iy. Ix value is 29.29, so this will become 29.29 plus Iy is 5.667 5.667 divided by 2 plus or minus root of, again this values 29.29 plus 5.667, sorry, this should be minus, divided by 2 the whole square plus ixy square. We have got the value of ixy as minus 9.3656 minus 9.3656 whole square, and this entire expression we need to multiply it by 10 to the power 6. this entire expression, we need to multiply it by 10 to the power 6, because ix and iy, they are multiplied by 10 to the power 6, and also ixy is 9.365 multiplied by 10 to the power 6. So I can keep this 10 to the power 6 as common. So therefore, I will get I1 as this term plus this term, and I2 will be this term minus this term. So let us put this expression in the calci, and let us see what is the value of I1. So I1 will be 29.29 plus 5.667 divided by 2 plus root of I get to put this bracket here, and then I can type this again, 29.29 minus 5.667 divided by 2, and then again I need to put this bracket, and I need to square this, plus 9.3656. I need to square this, and the value is 32.5525. 32.5525, and remember, we have this value multiplied by 10 to the power 6. And then if I if I find the if I want to find the I2 value, what I need to do is I can just change this sign to -2. I can just change this sign to minus. I can just change this sign to minus. From plus, I need to change this sign to minus, because this is I1 is plus and I2 is minus. And if I check this value, I'm getting this as 2.404. So this is 2.404 multiplied by 10 to the power 6. And then of course unit is mm raised to 4. This unit is mm raised to 4. Even this unit should be mm raised to 4. So these are the values of I1 and I2, and this is the value of theta p. This is the value of theta p. So we have been able to solve the first equation, that is to determine the magnitude and orientation of principal centroidal moment of inertia. Now in second sub question, he has asked us to determine the moment of inertia about the axis x1 and y1, which are rotated at an angle of 30 degrees. So I need to now determine the moment of inertia about x1 and y1, which are rotated at an angle of this theta is 30 degrees. For this, we have already derived the expression, and these are our expressions. We almost have all the required quantities in this. We know what is Ix and Iy. Again, Ix is 29.29, 29.29. Iy is 5.667. Iy is 5.667 divided by 2. I will keep that 10 to the power 6 outside, plus again same values, 29.29 minus 5.667 divided by 2, cos of 2 theta. So here theta is 30 degrees. He has asked us to find the moment of inertia of the axis which are oriented at an angle of 30 degrees. So theta is 30. So theta is 30. 30 multiplied by these two will be 60, minus Ixy sine 2 theta. Value of Ixy, we have got it as 9.3656. So this is minus 9.3656 multiplied by sine 2 theta of this, and about this 10 to the power 6. This value I have already written it outside, and then again this will be sine of 60. So if I put this in calci, I should get value of Ix1 as, let us put this in in our calci. Let us see what we get. So this will be, I already have this value with me, so I will not delete that. So I'll just go on deleting all these values. So this is the value which I already have, plus it is 29.29 minus 5.667 divided by 2 multiplied by multiplied by cos of multiplied by cos of 60 multiplied by cos of 60. Then this minus and minus, it will become plus I have 9.3656 multiplied by sine of 60, and I will get this value as 31.495. So this is 31.495 multiplied by 10 to the power 6 mm raised to 4. And then if I want to find Iy1, that is the moment of inertia about this new axis y1, then we know that this is our formula which was derived in last session. So if I substitute these values again, basically all these values will remain same. Only thing is here in place of plus it will become minus, and here in place of minus it will become plus, but the value of ixy is minus, so it will become minus here, as this was becoming plus, minus into minus, this will become minus here because of ixy. So what I need to do is, basically I need to just change the sign in the equation which I had already fed here. So this will become minus, and then this term will also become minus. So this term will also become minus, and then I get this answer as 3.4619. So I get this answer as 3.4619. So these are our new values of ix1 and iy1. Of course, I can verify this by using our equation, that is ix1 plus iy1 should be equal to ix plus iy. That is the sum of moment of inertia about the new axis x1 and y1 should be equal to the sum of moment of inertia about the original axis ix and iy. So the moment of inertia about the new axis which we have got are, of course, this should be again 10 to the power 6 mm raised to 4. So the moment of inertia about the new axis which we have got are 31.495 plus y1 is 3.4619 multiplied by 10 to the power 6. This should be equal to ix plus iy. Our ix was 29.29. This is 29.29 plus iy is 5.667, 5.667 multiplied by 10 to the power 6. So what we need to basically check is whether this value is equal to this value, and if we are getting that these two values are equal, that means whatever values we have found, they are correct. So this is basically can be considered as a validation step. So let us add them and check. So I have these values this side as 31.495 plus 3.4619, and if I add them I'm getting this as 34.9569. So this becomes 34.9569 multiplied by 10 to the power 6. And let us check now what we are getting on this side. We are getting this as 29.29 plus 5.667, and this value is equal to 34.957. 34.957 multiplied by 10 to the power 6. So this value is approximately equal to this. So whatever that means, whatever we have found here, whatever values we have found are absolutely correct, because we have done the validation of this expression. So this is how we can solve any problem of rotation of axis and principal axis.